let's have a look how we can create custom nodes. So you can create custom tasks, custom decorators, also custom composite nodes. You can do obviously in C++ if you want, or you can do in Blueprint. Let's have a look how to create a new task in Blueprint. Go to the new task here and then create a new task inherit from the Atoms Behaviour 3 Blueprint task node. We are going to replace the weight task with our custom weight task. So let's rename this one to BT Blueprint weight. And now let's implement this. So the task has three functions I can override. So there is the initialize, the update, and then the terminate. You must return a status value when you execute the graph here, and then basically during the execution, when the node start the execution, the tree called initialize, and then if you set a running state, or only at the first computation, you call the update, and then when the task return success, a failure, then you execute the terminate to terminate the node. So for our wait nodes, first we need basically to expose some variables. So we need an internal variable. There will be a float, and this is going to store our timer. So let's store the initial time. So init time, let's call it time. This one could be a private. We don't need to expose, and then we can expose the waiting time. This one can be an Atoms Behaviour 3 int property. This way you can access the blackboard key if you set one on the tree, and let's call this wait time. Okay, let's expose this one, and now let's put some code here. So we need to store the current simulation time when we initialize the task, and we need to store them inside the init time. So from the context, we can access the agent group. So we can get the agent group, and then from the agent group we can get the simulation time. The simulation time is in frame, so to convert in seconds we need to get also the get frame rate, and then if we divide those two we get the time in seconds, and then we can store that in the init time. Here we can connect this one, and last thing we need to set a running state, because we are going to execute this node on multiple ticks until the timer expires. Okay, so now initialize is fine. Now let's implement the update event. So basically we need the same code to get the current time here, and then we can get the init time, subtract those two, and then if it is higher than a wait time that we need to connect here, then this one go for branch, and then we can set a success status from the state, set success. Okay, now we need just access the wait time. So let's get the wait time here. Let's break this one because it's a structure. So we can take the initial value directly if we want, but if the user set a backward key, we need to handle that. So we need to put if here, and then if there is a key, then we need to get that key. So we need to get blackboard int value using the key name, and then we have the value. Okay, so let's connect this one to the branch. Here, probably we need to duplicate some code here. Let's have a look. Okay, so okay, so if it's true, then use this one. Okay, otherwise we need to use the standard value. Here, let's copy this one. Okay, should be, yeah, sorry, we need to connect, no, sorry, it was fine, we don't need the terminate, should be fine. So let's compile this one. Oops, sorry, state pin is invalid. State pin, yes, we need to connect the state. So let's take the state. Okay, compile it, save. Let's replace our wait nodes with the BT blueprint wait. Let's put 3 seconds. Save it. Let's press play. Let's have a look. And now it's working fine. So it waits 3 seconds, put 3 seconds there, and start again. Cool. Now let's try to create a blueprint decorator and try to replace the repeat decorator here. So let's create a new decorator. Let's inherit from the base class. Let's call this one BT blueprint repeat. And for a repeat, so we have the same initialize and the update. We have the terminate, but we don't need in that case, and then we have the on-child updates that we need. Actually, the update, we don't need update, but anyway, let's start to implement the initialize. So for the initialize, we need to basically start the its child. So we need to basically first check if we have a child. So we can check the number of children. If this one is higher than 0, so we are fine. So we put if, and then here, and then we can start our child using the start child function. here. So if it's false, we need to return set failure. And now if we start the child, then we need to set the state. In this case, so the status. In this case, we need a set a specific status, that is the status suspended, because the start child tell the tree to start the current child. So we need to wait what the child do before setting a proper status. So and for this reason we need to set the suspended status, because we need to wait for the status from the child. Now the initialize is correct, and then we need to implement the onChild update. The onChild update is called when the child changes status, so it can return success, failure, or running, or suspended as well. So for the repeat node, we need to basically wait that its child is finished, and then basically start again. So here we have the child status. So we need to compare with the so we need to check if it's running. We need to check if the child returns success. So here we put a if branch, because if you return success, then we can start again. So let's connect this one. So if the return success, then we'll start again the child. Otherwise, we just pass the child status to the actual to our decorator status. So we just need to basically set status and passing the status here. So if this one is false, okay. Otherwise, basically we need to basically replicate the code here. So we need to start the child again. Start again, and then this time we need to set the status to running, because we are currently running the repeat node. So if we play like this, should work. Obviously this one is in an infinite repeat. So let's have a look if it works. So it's bt blueprint repeat node. Put here, save, and let's have a look. Let's press play here, and then you see that we're running. And then start again. So it's working fine. Obviously you can expose the number of repeats if you want as a variable, and you can expose as Atom's behavior tree property. This way you can access a blackboard key if the user set a blackboard key on the output here. But yeah, the logic is basically explaining this one. Close this one. Let's remove our repeat. Let's keep our looping decorator. Okay, so now let's try to replace the sequence with a custom behavior composite node that do the exactly the same logic. So create a new composite node. This is going to be our bt blueprint sequence. So it's really similar to the decorator that we just created. So we have the initialize, and then we need the onChild update. Probably should be that's it. So we just need to replicate the initialize. We need to replicate the initialize of the decorator we just created. So we need to check, get the number of children. If this one is higher than 0, then we can start the child. Otherwise, so we can start the first child. Otherwise, we return failure. Set failure. So we need a variable to store the current child, and this one will be integer current child. And we need to start from 0, so put the 0 there, and then we need to start basically the child. So start child from the 0, and then we need to set this. We need to set the state. Sorry, the status to suspended, because we need to wait the first child to start. Or if on, yeah, no, let's put sorry, put suspended here when you initialize the first time that you initialize the first child. Okay, so now on the child update, so we need to check the status. So if the status this one is equal to success, then we need to basically execute the next child. So if put here, otherwise otherwise we need to pass the status and set the status directly from its child. Set status, and okay. In this way, if a child return failure, then also our sequence return failure, so it's the correct behavior there. So now let's have a look to the success case here. So we need to basically get the current child. Sorry, and the current child. Now we need to add 1. Because we need to increase and go to the next child. We need to check if this one is higher and equal to the number of the children. Get number of children we need to return success because we finished, because we executed all the children. That success. But if here okay, and this one go through here from the condition. Okay, otherwise we need to execute the next child, so we need to do run start child, and will be our new value here. And then we need to store the new value of the current child. So get, sorry, not get, but set here, and we need the new value. Okay, so should be just that's it. Let's compile it and save. Let's replace the sequence with our blueprint sequence. And then this one, and this one. Okay, let's play. Let's have a look if we done it all fine. Yeah. Now pass to the last one, and then should be go back, do it to our custom repeat. So working fine. So one quick note about the blueprint nodes that you create here. So every time an agent executes one of these blueprint nodes, if the blueprint node does some variable here, then he basically create a new object and clone the new object from the asset, because obviously in its own basically its own stack to store the variable. If the memory allocation is a problem for you and see that is affecting too much your performance, what you can do is to remove the variable here and, for example, store the data that you want on the blackboard directly, or if you want, you can store directly on the agent metadata, because here you have access to the agents. In this way, the behavior tree doesn't clone this object, because it will be just basically static function without any local variable, and this way it doesn't call the allocation memory. So thanks for watching. See you in the next video.